Hello, this is Unit 1, Introduction to Environmental Management. So, you can think of this as an overview, basically. This is just an overview unit, so it's a very simple unit. Shouldn't be too long. So, we're going to start with 1.1, which is about the continents and the ocean. So, in the world, there are 7 recognized continents. Why can't I spell? Continents. Okay. There are 7 continents, and those are Africa, Antarctica, Asia, Europe, North America, and, South America, and Oceania/Australia. Now, these are kind of interchangeable terms, and in the course, usually Oceania is used. But remember that there are 7 continents. Now, this you just need to know that there's 7 continents, but for the oceans, you're going to need to know some details, so just listen up. So there are 5 oceans, and those are Atlantic, Pacific, Indian, Arctic, and the Southern Ocean. These are all, you may know it from different names, but these are the ones known in the AICE Environmental Management, AS level curriculum. So here's what you need to know about the oceans. The Pacific Ocean is the largest and covers 33% of Earth. The deepest point of it, which you need to know, is the Mariana Trench, which is at 11,034 kilometers. The Atlantic Ocean, the Atlantic Ocean is the second largest. It covers about 20%. Sorry, just ignore that. 20%. Right. It has, this is important, it has the highest salinity of the oceans, which means it has the highest salt content. Now, this is also split into north and south at the equator. The Indian Ocean is the third largest. Southern. It surrounds Antarctica. And the Arctic Ocean is the smallest ocean around the North Pole. So really what you need to remember the most is, here, I'll underline what you need to know the most in red. You need to know that the Arctic is the smallest. You need to know that the Atlantic Ocean has the highest salinity. And you need to know that the Pacific Ocean is the largest and has the deepest point. Sorry about that. Okay. Now we're on to Unit 1.2. So each country has classifications. So country classification. Now in 1.2, we're classifying it by income levels. Boom, boom. Okay. So these are by the World Bank. Classifications by the World Bank. Let me be more specific. So you have an LIC, which stands for Low Income Country, which the gross national income is less than or equal to $1,035 USD. This is all in units of USD, so I'm not going to rewrite it, but just know that's what it is. Some examples can be Ethiopia, Haiti, and Afghanistan. There's an MIC, which is a middle income country. And that's where the GNI is between $1,036 and $12,535. Examples of this can be India, Brazil, Jamaica. Now remember, sometimes MIC, the middle income countries, aren't always included. So a lot of the time, MICs will be considered LICs. So just take that into consideration. At least that's what I've personally seen. An HIC is a high-income country. So that is the GNI, which is the gross national average, is greater than or equal to $12,536. Examples of this are the countries you know: the United States, the United Kingdom, Australia. I just want to do a quick note right here. We'll do that in yellow. Note: GNI stands for gross national income. Alright, so now I want you to just remember some of this stuff. So typically, an LIC has the following characteristics. It can have poor water quality. They tend to have less factories, so they sell more raw materials. They typically have high immigration. So immigration is basically the opposite of immigration. As you know, immigration is people coming in. Emigration is people leaving. So obviously, poor conditions cause a lot of people to leave. And HICs, common characteristics of this is they have clean water. They often buy a lot of raw materials from these LICs, so they get them for very cheap. They often have a stable government and low immigration, because if it's good, why would people want to leave? What you need to remember really is that LICs usually sell raw materials. They have a lot of exports. So you could even say like they export raw materials. And they also have very poor infrastructure. So no factories, poor water. You got to remember that the HICs are very developed and stable. So those are developed and stable. Okay, now we're on to Unit 1.3. Sustainability. Excuse my handwriting. As you can see, it's pretty bad. So sustainability is, you need to know this definition. I will do the red. Boom, 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 boom. Okay. For that. Sustainability is meeting the present needs of a country without harming future generations. You really don't need to include this part. This part's yellow because you don't really need to say of a country. So you probably get higher marks by just saying meeting present needs without harming future generations. So there's renewable and non-renewable resources. So renewable resources are resources that can be, well, reused and are not just like fully disposable. So remember that these are replaceable. So renewable resources are replaceable. Some examples can be soil, fresh water, wood, stuff like that. Non-renewable. Some non-renewable resources, these are limited. That means there is a finite number of them. Remember the word finite, that's a good word. It's a good word to use. Okay, that one's not dismissible, I gotta do that. Alright, some examples of this could be fossil fuels, like oil. Oil, there's a limited amount of oil in the, or there's limited amount of diamonds, so like minerals. Yeah, these are just a few key examples. So a few things that you just really need to know for this unit is the ecological footprint. And what that is, footprint. There we go. Ecological footprint. It's the resource use. Source use plus the waste production of someone. So if you know, like, your carbon footprint is similar to this. It's just like how much you're using and putting out there. And then there's also the natural capital. So think of it like this. It's the natural cap in a way. So like the natural cap. It's like the total amount of Earth's resources as well as like a combination of the ecosystem services, which kind of helps them. So now I'm going to need to make a new page. We'll start the next unit up here. Okay. 1.4, the water cycle. And just like that, we're almost halfway done. So there's a few key processes of the water cycle. I'll write these in. Let's go blue because blue for water, right? And make a water droplet. Okay. That's water. So, there's through flow. Which is water moving through soil. So, this is the easiest way to remember this is through, there you go. There is, I'll keep that up there for you. Interception. which is water that's caught. So think of it like this. It's being intercepted. It's all, let's say it's raining, but there's a tree. I'm going to draw this for you. So it's raining. There's all this rain. But the issue is there's a tree right here. Now, all of the water, all this water right here, is being caught by the tree. It's being intercepted by the tree. So it's water that's caught by trees or buildings or other things that are intercepting it and using it for their own use or just holding on to it. There is infiltration, which is the process of when water infiltrates and enters the ground. So the water enters the ground. Simply just like that's the soil, the water goes in, which can also be connected to through flow. And then there is runoff, which is when water is flowing on the surface. So, I'm just going to quickly add a few more pages. You may notice that these videos are just fully unedited. So, yeah. Just bear with me on these, you know? Alright. So, groundwater. So groundwater, if you think about it, really isn't on the ground, typically. It's usually stored in aquifers. And what an aquifer is, you guys love my graphs, I'm sure. So the black is going to be the ground. So that's the ground. So now under the ground, we have a bunch of rocks. And then there's this kind of like cave in there. Or if you even want to think about it more, the cave could be like over here. And what happens is water infiltrates. It infiltrates the soil. And then it kind of flows through flow, and fills up this aquifer with water. Okay. So aquifers, they are refilled by groundwater recharge. Now, here's the issue with aquifers. Issue, right? The issue with aquifers is that a lot of the time, ocean water enters, which contaminates it. This is called saltwater intrusion. So sometimes it also has the cone of depression, which is when there's an overuse of it and the water table drops. So some things that can pollute or like contaminate is a way to think of pollution if you don't know what the word pollute means. Something that can pollute these aquifers, or just typically any water sources, excuse me, is fertilizers or pesticides, animal waste, like septic tanks, that's human waste also, landfills. You'll learn like in later units that leachate is liquid from landfills that comes out and really pollutes pollutes groundwater sources. Gas stations, gasoline, and like urban runoff. Even like acid rain can, but I'm only writing like the key ones. So there's a closed system and an open system of water. Just remember those. So now I'm going to go on to Unit 1.5. If you don't know what an open and closed system is, let me know in the comments. I can go more into depth with it. But I'm just not really covering that right now. I will cover that more when we get into the water unit. I think that's Unit 3, but I might be wrong. Okay. So the composition of the atmosphere. What color is the atmosphere? We'll go green, right? So the composition of the atmosphere is as follows. It is 78% nitrogen, 21% oxygen, 0.4% carbon dioxide, and it also contains small amounts of other gases. Excuse me again. So there's also the 5 layers of the atmosphere. We'll go back to black. 5 layers in order are troposphere, stratosphere, mesosphere, and the thermosphere, and the exosphere. Now, Unit 1 really doesn't recognize the exosphere. That's more in the atmospheric units, but we'll just talk about it still. So the troposphere, here's what to know. The troposphere, is the closest to Earth. This is where weather occurs. The temperature decreases with altitude increasing. And it contains greenhouse gases. Sorry for all my coughing. So the next one is the stratosphere. Now, the main thing to remember the stratosphere is that it contains the ozone layer. Now, the ozone layer is very important, so you need to know that it's inside of the stratosphere. That'll come up later in other units. Temperature increases with altitude increase, and this I don't have room to write it, but it also absorbs UV radiation. So the mesosphere is the coldest layer as temp decreases as altitude increases. Now the thermosphere is very hot. It gets up to 1,000 degrees Celsius, and this is also where auroras occur. And the exosphere, remember, I'm not really going to cover it that much. What you really need to remember about each of these, I'll highlight in blue. What you need to know is that the troposphere is where weather occurs. The stratosphere is the ozone layer. You need to know that the mesosphere is the coldest layer, and that the thermosphere is the hottest. So now we're moving on to Unit 1.6. Ecosystems. So the levels of organization in an ecosystem are, I'll just say in black, population, which all contain the same species, a community, which has multiple species, an ecosystem, which contains all living and, ignore all. It contains living and non-living species. A good way to remember population is the same species. Is to remember, whenever people talk about like population, they say the human population or the population of German shepherds. Like, they're very specific on it, so it's just a certain amount of a species which are the same. And there's a biome, which is just a large region. Now, some good terms to know are habitat, which is where organisms live. It is where an organism lives. And a niche. That's pretty niche. Sorry about that. Is the organism's role in their habitat or community. So an ecosystem has components. So the ecosystem components are, there's two parts. Abiotic and biotic. Now, abiotic can be things like the water, temperature, sunlight, climate, things like that. The soil, it's a good one. Biotic things can be producers, consumers, decomposers. Now, biotic means living. Now, obviously, abiotic is the opposite, which means non-living. So now there's also trophic levels. So I'll just tell you the first four. So there's producers, primary consumers, secondary consumers, and tertiary consumers. Now, an important thing to note here is that only 10% of energy is transferred among levels. Now, this is very important to remember. So let's say the producer has 1,000 units of energy. We'll just go with 1,000. That would mean that once it gets to the primary consumer, there's only 100 left. By the time it gets to the secondary, there's 10 left. And then it gets to the tertiary, there's 1. It's a very important thing to remember that comes up a lot. I've already got to add more pages. I'm going to add Sorry about that. Whoa, it's glitching out. We'll just stick to the 2. Sorry about this, guys. Okay. Whoa. Came all the way back. What are we doing? Oh, I forgot about my diagrams. There we went. There we go. Whew. Looks like I forgot the Y in secondary. Okay. So, food chains show energy transfer. So, it's not... Okay. Food chains, they show the energy transfer. That's the 10%. And they typically have 4 to 6 organisms. Now, when you're reading a food chain, the arrows mean the energy flow. Just remember that if you have to read one or you have to make one. Photosynthesis. It occurs in the chloroplast. And it uses sunlight. You gotta remember that. Now, I'm gonna give you the formula for photosynthesis, which is given here. But I've seen a lot of questions on mock papers and practice exams, and past exams is what I'm really saying, of a bunch of, you can get 1 or 2 marks by literally just giving the formula. So I'm going to give you the formula here in red, the equation, and it may come in handy, it may not, but I would say memorize this. If you get any formulas, memorize them. So 6CO2 plus 6H2O creates C6H12O6 plus 6O2. You can remember that. Now, factors that limit photosynthesis are the amount of light, the amount of CO2, the temperature. So, cellular respiration, I don't know why that was so hard for me to say. This is how, here we go. Cellular respiration, it releases energy, or ATP. The equation of cellular respiration is glucose plus oxygen creates CO2 and water. Give me a second. I forgot what glucose is. Okay, that's what it is. So the formula, the equation, is C6H12O6 glucose plus O2 to create CO2 plus water. Or what I'll do here, H2O. Let me double check that, actually. That's what I thought. 6O2, 6H2O, 6CO2. So it is actually the opposite of photosynthesis. Sorry about that, everyone, to my audience, if anyone's watching. Okay. Now, the carbon cycle it has abiotic components which I remember, what are they? Yeah, that's right, non-living, such as the atmosphere, the oceans, and fossil fuels, these are all part of the carbon cycle. And biotic are living, so living organisms, which move via photosynthesis, respiration, and even decomposition. So there's different ways that biotic factors, I guess you could say, interact. So these are the biotic interactions. Promise you, we are almost finished. So one of them is competition. Competition can be either inter or intra-specific. Now note the difference between these two. Intraspecific is within the same species, while interspecific is within different species. Another one is grazing, which can be like eating parts without fully killing it. Another one is predation. I think I'm saying that correctly. And that's when the predator kills the prey. There is parasitism, not really sure how you say it. And that's when there's one who's benefiting and one is harmed. So there's two terms for this. There is ecto, which is outside, and there is endo, which is inside. Maybe ecto out. Maybe that's the way to remember it. I don't know if that'll work for you. And then there's also mutualism, when they both benefit. So remember that energy decreases differently in the trophic levels. So it's over here. Sorry. The energy, 10% of energy only transfers to each trophic level. You can think of it as 90% is lost going up each trophic level. You can see that photosynthesis and cellular respiration are the opposite. That's very important to remember. And then the biotic interactions are those are the relationships. So it's the relationships of the species. So yeah, thank you so much. If you have any questions or need me to review anything in more detail, please let me know in the comments. Please like the video, share it. And this is just a very basic unit. Everything in here gets more into detail. Thank you.